Have you ever wondered how a spider weaves its silk, or how a gecko can hang from the ceiling by just one toe? Have you ever wondered how water insects can stride across the surface? Have you ever wondered how a chameleon can change its colors to blend with its surroundings? Or better yet, have you ever wondered how you yourself could camouflage it? This is the field of biomimetics. Biomimetics, or biomimicry, is the emulation of creatures' solutions to nature's problems in application to engineering sciences. Modeling designs after nature is kind of a form of Darwin's theory of survival of the fittest. Nature's been dealing with problems for centuries and centuries and centuries, and through evolution, creatures have learned how to deal with these problems. And biomimetics is the application of that to engineering. Velcro was invented by a scientist removing burrs from his dog's fur. The Wright brothers modeled their elementary airplane wings after the wings of birds in relation to the speeds at which their aircraft was designed to fly. It's a very fascinating field. It's groundbreaking right now. Think of any problem you have, and in consideration of that problem, think about creatures' solutions to the exact same problem. Chimps, for centuries, simians are very similar to mankind, and they've been dealing with the same illnesses that humans have for a long time. And they've been ingesting various herbs and medicines from different foliage and plants around the world. And over time, they've learned what plants cure their specific ailments they have. Doctors today are facing the exact same problem. They turn to chimps. And biomimedically observing these chimps, they can see nature's solution to the exact same problem. So today I'm going to talk about biomimetics. I'm going to present to you multiple case studies. As you can see on the screen, we have a biomimetic jellyfish. They're examples of flying biomimetic robots, swimming, walking, crawling. Here we have Cal's frog. You've all heard of Boston Institute's walking dog. It's quadruped. There's a cockroach, a snake, a penguin, a stingray, and an entomopter, which is the first case study I'll present to you guys today. An entomopter it's a micro-aerial vehicle that can both crawl and fly. Its applications in the military include reconnaissance, undetected reconnaissance specifically. It's about the size of a housefly, and you can mount a camera to this thing to essentially make it this indetectable spy that can relay real-time video and audio feedback to base, or however you want to apply this. It's based off 3 animals. Those include the housefly, the hummingbird, and the hawk moth. It inspires its size, its weight, and its dual wing structure from the common housefly. Its air maneuverability and its control it has with its flight is modeled from the hummingbird. You've all seen them hovering outside your window. And then the wing shape is designed after this specific type of moth. And this is an example of biomimetics in action today in our own homeland security. My second example comes from kingfishers. This is regarding the fastest train in the world, the Japanese bullet train, travels over 200 miles per hour. It has a specific problem, and villagers started complaining because whenever it exits or enters a tunnel, the immediate difference in air pressure creates a thunderclap. Within about a mile radius, villagers are complaining from the noise. And so the senior engineer on this project, he was an avid bird watcher. He thought to himself, where do I see in nature a high, fast velocity creature attempting to cross 2 mediums with little to no disturbances? And he turned immediately to a kingfisher, which is a bird who dives through the air-water medium to its prey with little to no splash at all. Inspired by this, he designed the nose of the bullet train to be shaped exactly like the beak of the kingfisher. This not only reduced the sound it created from the thunderclaps when it emerged from the tunnel, but it increased the efficiency and speed of the actual train itself. So as you can see from the 2 examples I presented here today, biomimetics it's currently a groundbreaking research field that solves problems because nature has been experimenting in its own laboratory for millennia, and we would be ignorant to not pay attention to that. The entomopter, military applications, kingfisher, even pleasant, peaceful village applications. Biomimetics has a broad range of applications. So to leave you guys today, I'd like you to consider your engineering future. I'd like you to think about your careers and the problems you'll face when you graduate and become engineers. For you ocean engineers, the next time you design a ship's hull, I'd like you to consider a dolphin's hide and how it deals with stress variations at different pressure depths. For you structural engineers, I'd like you to consider next time you design a building's air conditioning, consider how termites ventilate their own mounds, regulate their temperature. And for you chemical and bioengineers, next time you're pursuing that medicinal elixir, think about the chips. Let them solve your problem. Thank you.